All right, so what happens when things are different? That's what we're going to look at today. We're going to start off with a couple of different forms. I'm going to do this 2.7 in a two-part series. We're going to do part A, part B, just because I don't want the video to be 20 minutes long. So first we're going to begin on page 45, where it says X marks the spot. Some of you may have seen this before, but this is just kind of one way to try and help you multiply binomials. If you look at the example that they give you and then problem A, they give you the two side numbers. So how do I get the top number from 7 and 8? And most everybody says, yes, multiply. So 2 times 7 is 14. You need to do that in a different color just so it stands out. How do I get 15 from 7 and 8? Most people say you add. So 7 plus 2 is 9. So you would continue that concept. 45, 9 and 5 is 14, and you continue that concept through the first page. So go ahead and do that. That'll probably take you less than a minute. Go ahead and pause, do that, and then come back, and we'll talk about the other one. All right, so if you finish that and paused, you come back, and now you look at page, what is this? Page 65, I believe. We'll go down to the bottom and see. Yep, page 65. So 2.7 warm-up. We skipped section 2.5. We did 2.6. I should have done the warm-up a while back, and I did not. So we went and did that. Now we come back here. Now what do you notice that's different? Same numbers, almost, but things are a little bit different. We're still keeping with using the two numbers on the side. And what you should notice is now all of a sudden we have one number that's negative. Well, positive times a negative gives me a negative 56. Now I add these numbers together, but instead of getting 15, what do you get? You get a minus 1 because you have a negative 8. Yes, I still said add them together. Even though they're negative numbers, we still add them. So if I multiply, here's how to do this. If you get confused, and this is practice on how to do this, 7 times 2 is still 14. But a positive times a negative is negative. Now when you add them, I have more negative 7s than I do positive 2s, so the result is going to be negative, and you just subtract the two numbers, 7, 6, 5, so the answer is negative 5. Let's do the next one. Again, B, negative times negative is positive, 5 times 9 is still 45, just like it has been before. And now I'm going to go ahead and subtract the numbers. Well, gee, if I start at negative 5, and I add negative 9, I'm moving to the left, which is a smaller negative number. I end up with not positive 14, but negative 14. So go ahead, there's your other warm-up. Think about that, and we'll talk a little bit more about the magic X here in a little bit. All right, moving on. What are we going to do in this pattern? I'm not going to do every problem in this for the sake of the video, but I will give you some helpful advice on a few of these problems. So what we need to do is we need to find patterns in signs and numbers to help us multiply. We're going to use some models to help us multiply those. We're going to use model diagrams to factor trinomials, and so on. So question number 1 starts with a review of what we did before. What if the original block that we start with, right? There's my original block. What if that was the standard length on one side and 2 inches bigger on the other? This we should be able to do. One side is x, the other side is x plus 2, and I'm going to go ahead and just increase that. How do I express the area of this? The area of this is expressed as x squared plus 2x. Or I can express it as both my factors, length times width. All right, so there's your two for that. All right, so now we get into question number 2. What if they want a block with a standard length on one side, but 2 inches less on the other? Well, we start off with my standard block, okay, x by x, but now they want one side the standard length, so I'll make that. They want the other side 2 inches less than. Well, what less than insinuates that we subtract. So it looks like I'm going to add 2 to both sides, but really I'm not. I have to identify my model somehow to show that I'm using subtraction, and that's simply some shading. Right? So the shading shows me subtraction. So length times width. All right, so if I'm going to express, I'm going to get equals x times x minus 2. And my other one, again, Find the area of all the little pieces and add them together. Well, the area is x squared, but I have minus 2x's. There are no single little boxes, so there is no constant value. All right, now we get into 3, 4, 5, and 6. And I'm going to look at question number 3. And then we'll kind of skip ahead of here a little bit. Question number 3 is 1 inch less than, and the other side is 2 inches more than. All right, so I've got a couple of things happening here. Go with the first side. The first side is 1 inch less than, so that's x minus 1. Well, I gotta shade that off, right? The other side is 2 inches more than, so that becomes x plus 2. Well, gee, x plus 2, complete the model. But what you have to remember here is when you're dealing with signs, positives and negatives, negatives rule, essentially. So I have to continue the shading all the way across. Well, find your area, or express your area as your factors, x minus 1 and x plus 2. What you will notice is that if we find the areas of all my little pieces, I get x squared. Now, here's where you have positive 2x's and minus x. Remember, what do we do with these two sections of our model? We combine them, right? We add them together. I'm adding them, but I have positive 2 and minus 1. That leaves me with plus x. That only leaves me with 1. So one kind of cancels out the other. And then what do I have at the end? I take away 2, because I'm subtracting those two. All right, let's look at one more, and then we'll move ahead. So one is 2 inches less than, the other is 3 more than. Again, start with your basic block. Okay, so 2 inches more than, or excuse me, less than, 2 inches less than, so those are going to be shaded. And one side is 3 inches more than. So 1, 2, and I'm going over into the next question, 3. That's fine. Finish off your model, but remember negatives rule, so you have to finish that off. So here's x plus 3, and you have x minus 2, and then you're going to write your two equations that represent the area. You're going to have x minus 2, it doesn't matter which factor you put first, x plus 3, and then you're going to go ahead and you're going to find the area of all the little pieces and add them together. Well, I have my one big x squared, so x squared. I have 3 x's here and minus 2 there. Remember, you add those two together. So what is plus 3 minus 2? Well, plus 3 minus 2 is plus 1. So x, and then I have my 6 little segments there that I need to subtract. Remember, what do these do? These two factors here add to give me the middle term. They subtract, they multiply to give me the last term. Negative times a positive is negative. All right, so pause and pick two of 5, 6, and 7 to work on. Question 8. Don't want to deprive you of anything out of the notes here. So question 8. How do we determine, look back and see, how can you tell the middle term is going to be positive or negative? Basically, if, and you can rewind this, if there are, and this is horrible, if there are more positives than negatives, okay, if there are more positive x's, if there are more positive x's than negatives, okay, more positive x's than negative x's, the result would be positive. And vice versa. If there are more negatives, then it'll be negative. Right? That's how you can tell. So, like, go back and look. Go back and look. Here, more positives than negatives. B is going to be positive. More positives than negatives. B is going to be positive. We go up before that. Right? More positives than negatives. B is going to be positive. There was only a B value there. Right? So that's how we were able to tell that. And then the other, in question 9 there, one customer said, hey, what if we take the basic block, and what if we add 2 to one side, but we minus 2 from the other? Are we going to end up with x squared. Is this going to be a of x? A of x, is that going to be equal to x squared? Is that just going to be x squared? Because that's what we start with, right? Well, go ahead and complete the diagram. Add 2 to one side, subtract 2 from the other side, do all your shading, do all that type of stuff, and then come back in a second and we will explain. Did you do it? You probably didn't. But if I add 2 to one side and I take away 2 from the other, complete the model. Remember, you have to shade the one side. So find the area of all of your little pieces. You know what one of the sections looks like. It looks like x plus 2 times x minus 2. Okay, or one of the expressions rather. Okay, so x plus 2 times x minus 2. Remember, we add these two together. What's plus 2 minus 2? It's 0. So you should get x squared. If you add the area of all these little pieces, remember, what do I do here? I add. Plus 2 minus 2 gives me 0. So do I write plus 0x? No, we don't write that. But you don't forget about the last piece over here, which becomes x squared minus 4. So you actually end up with less if you add the same and subtract the same. You actually end up with slightly less. That's what they wanted you to understand. So now when we go on and we look at 10, okay, we can look at the result here. If I have the same, I square the first term, so x squared, plus these two to get my middle term. Well, gee, that cancels out. And I multiply them. Positive times a negative is negative 1. Or over here, I square the first term, I square the last term, but what's the sign? Is it positive or negative? Well, positive times a negative is negative. Because I add them to get my b value. Plus 3 minus 3 is 0. All right, and then question 11, where we're going to finish up. It says, what pattern do you notice? And basically, what we notice, and I hate examples, I really don't like examples with letters, all right? But what we notice here in question 11 is, what do you notice? Okay, this is equal to x squared minus a squared. That's not 9 squared, that's a squared. That's a horrible looking a. All right, that's essentially what that is. Okay, so there's the first half of this. Ask questions if you need to.